So here we are, we reached the final topic of the day, anonymous functions. And this is an interesting one. One reason that it's interesting is because anonymous functions are not a part of PEP 8. So what that means is that the creators of Python and Guido van Rossum himself write a list of best practices for doing Python, and they explicitly say, hey, do not use anonymous lambda functions, just use standard functions with a definition. But obviously they still included lambda functions and anonymous functions in Python, and there's a reason for that, because they're powerful, curious, and quite interesting, and other developers like them. So in case you see them in code, this is how they work, and this is what they're all about. So anonymous functions are called lambda functions. You will recognize them because they're going to have that keyword lambda in there. They do not require to be named. So you can have a lambda function without a name, but typically like 95% of the time they're going to have a variable name at the start. And even that is tricky if that variable is actually naming the function. You can always check the type, but you can just, they're called anonymous functions for a reason. And another reason that they're anonymous is that they're like undocumented. So a typical function, particularly in a large code base, would have like the triple quotation marks at the start of the function. That's the doc string. So you can bring up in the documentation like what each function does and print out the doc strings. Well, anonymous functions don't have doc strings. So they're capable of having no name, and they definitely are, no doc strings, undocumented. Hence the name anonymous. And, well, they're usually throwaway. So you use them once, twice. They're not sort of a regular feature in the code that you're using. And this is the best part. This is why they're cool. The whole function is one line. So just you have like name, for example, lambda, your arguments go here, and then body of the function, the body, like after the def, is entirely just one expression. So the whole function is one line. So the syntax is as follows. So you have the word lambda, argument list, and then the expression. So here, before lambda, you could have a equals to lambda argument list expression, and that's the function name. So let's check out some examples. So the simplest one I can think of is just adding. So here we go. Add equals lambda x comma y, your arguments, the expression, so that's what it's going to return. So you can print add 2, 3, the output is 5. Now, this, is not exactly a super useful piece of code, but if you use lambda together with, like map or filter, I'm going to bring up an example of map function here. It can be pretty powerful. So you have a list of values, and you want to do a mathematical operation on every single one of those values. And that mathematical operation is x plus, you will add one to the value and then square it. So you're going to basically take some equation, plug the value into the equation, and get an output. So let's say you want to get the result of basically putting all of these through this equation in a form of a list with 1, 2, 3, 4, 5, 6, 7, 8, with 8 items in it. So you can have a variable name, final list equals to, so list, the result's going to be converted to a list. You use map. So basically with map, you perform this function operation on each one of these values. So when you print the final list, you are going to have, 1 plus 1 squared, that's 2 squared. 2 plus 1 is 3, squared is 9. 3 plus 1 is 4, squared is 16, and so on. So that's it. Those are some examples, and I think it's time we have a look at them in code. So here we are, the very last programming video of the lesson. So here we're going to look into anonymous lambda functions, and we're going to look at two really common use cases. One, to do math equations, and two, to basically process entire lists of elements in some way. That's going to use the map function, and the list that we'll be processing is a list of months. And we're going to convert each month to an abbreviated 3-letter month abbreviation. And we're going to return the list of these months. So it's going to be pretty awesome. Two common use cases, lots of fun, particularly if you like math and physics. So let's start with a common equation. Kinetic energy. Kinetic energy is mass times velocity squared divided by 2. So we literally can copy these mathematical expressions and have our lambda function return them. But first we're going to start by, well, naming the anonymous function. In this use case, really, naming it makes a lot of sense. We can give it a name, kinetic energy, and kinetic energy can be equal to lambda. It takes in 2 parameters, and the first one of which is going to be mass. The next one is velocity, and the expression is, as I have already written it, is mass times velocity squared divided by 2. Now, just to make sure that the top gets processed first, I'm going to put in these brackets, but these brackets are not absolutely necessary. So there it is. In the very next line, we can test it. Print statement, you can just put something like, kinetic energy, and this is where we call the lambda function, kinetic energy. So at this point, you gotta enter a mass and velocity, and I'm just gonna pick something like from every day. You can measure Usain Bolt's kinetic energy roughly. I don't know what he weighs though, so maybe like do a cyclist. So a cyclist and a bike maybe weigh like 85 kilograms. They go about 20 meters a second, and you can print that and even say joules. So in these 2 lines of code, we just calculated the kinetic energy of a particular cyclist, applied an equation, had a function that applies an equation. So as you can see, really, really powerful, do a lot with a little. With just a little bit of modification, we can actually convert the next one, mv squared over 2, to E equals mc squared. So at this point, the arguments are m and c. What it returns is mc squared, not over 2. But we do have a little bit of an issue, is that c here is the speed of light. And I'm just going to quickly Google speed of light. And this is going to be, a 9-digit number. And I think this is a perfect place for a default argument. So we should be able to, I'm just going to call this mass energy. So in this example, we should be able to run this function without actually specifying c, because the speed of light doesn't change, it's a constant. And if for some reason you wanted to specify it, maybe you wanted to do a float with a bunch of decimals, maybe you're really concerned with precision, you could specify it if you want. So here we are, we're going to do the print statement, mass energy, and we're going to call the function mass energy, and let's pick, something realistic. You're going to lose a fraction of a gram, so it's going to be something like 1/1000th of a gram. And the speed of light, since it's already specified right there, you can actually ignore it, and this should work. So that kind of shows you what's interesting. A cyclist cycling at a really high speed of 60 something kilometers an hour, or even up to 80 kilometers an hour, 20 meters per second, has way less energy than 2 millionths or 2/10 millionths of a gram of mass converted into pure energy. I just thought that'd be a fun demonstration. So next, gravitational force. This is the very, very famous equation for which Newton invented, which is force equals the gravitational constant times the mass of one body times the mass of the other body divided by the square of the distance between them. We do, instead of distance, often put because we're talking about, a mass of an object on Earth, and the distance between the center of that object and the center of the Earth is the radius of the Earth. So a little bit of a longer expression. So let's see how we go. So gravitational force is going to be the name of this function. That's going to be equal to lambda. That's going to take, see, g is a constant, so we can basically ignore that. So we need m1, m2, and m1, m2, and And this is, the reason I picked this is because we can go back to keyword arguments. By default, you're on Earth. So by default, one of the two objects is going to be the Earth. So I've got the mass of the Earth here in scientific notation. So 5 times 972 times 10 to the power of 24. Easily written in Python, actually, surprisingly. So we got mass 2, that has a default value, is the radius of Earth. So let's go radius. And that is just 6,371 kilometers, which is 6371000 meters. So that is the default values for M and R. And the equation is going to be this one. Capital G, and this is the problem, we're going to have to replace capital G with a gravitational constant. That might take a little bit, times 10 to the power of negative 11 times 10 to the power of minus 11. So really unwieldy, lots of maths happening in one line, but what we're doing is fairly powerful. We are entering a number of default values here. So we should be able to just measure the gravitational force on me right now. At the moment, I weigh 84 kilograms. So we can print my gravitational force and then call gravitational force 84. Run that. My gravitational force. And should do comma. So essentially doing 2-line physics equations calculators with Python lambda functions, which are really, really neat. Effectively, the body of the function that returns a value is just one line. So that's pretty fantastic. But if I wanted to measure gravity between, me and perhaps my fiance who weighs 62 kilograms, as long as M2 is the next value, which it is. Oh, and the distance between us, not right now, but let's say it's 2 meters. We should get something really tiny, actually, if everything works. Yeah, 8.6 times 10 to the power negative 8 newtons. So there you go. That's that curiosity. So we finally reached the point where we want to process all of these values with a map function and do a lambda that converts all of them to a list. So let's get started with that. Now, the syntax of this is going to be a bit tricky because we're going to have a list function, and what we're going to be putting inside the list function is a map function, and inside the map function is going to be the lambda function, which actually does the month conversions. So let's just perhaps break it through with steps. We're going to do the map function first. Now, we can't really print map functions, so we won't be able to see our progress, but first I just kind of want to show you what the syntax of this is. First, we're going to apply a lambda function, and we're going to apply it to that list of months. So let's start with what function we're applying to each item in the list of months. So the function that we're applying is, let's just say we have a month in the function, and what we're doing to each month is taking the first 3 characters, so up to 3, that's going to include 0, 1, 2, so month up to 3, and we are going to basically take this slice and then uppercase it. And this is the operation we're applying to every element in that list. So we need to save this output to something, and we need to save it to a list. So we can call that list ABV months. And this is not quite it, because what we have, if we were to try to print this, if we were to try to print ABV months, it'll just say something like map object at some location in memory. So we need to now convert this map into a list, and in one line, we should have that thing done. There you go, Jan, Feb, March, beautiful. So just to reiterate one little point and reformat this, is that this is a truly anonymous lambda function. This function has no name. The ABV months is not a function, it's a list. So if we were to basically print type, ABV months, you would get a list, and if we were to print the same thing for any of the other lambda functions, you would get function. So if we picked mass, energy, or any others, you're going to see the type of the first one is list, the type of that is function. So I thought it's really good to actually have a truly anonymous lambda function that we're using together with the map function, which is something that's a common use case that makes lambda functions even more powerful. All right, that's a wrap for anonymous functions and a wrap for videos in the list.